where I welcome Toni Ramchandani, Vice President at MSc INC, and he brings a wealth of expertise and insight to the field of data management and AI application. And this session promises to provide comprehensive exploration also in the realm of AI, and also it will be a lab session, so it's going to be interactive and interesting. So yes, over to you, Tony.
Yeah, thank you, Omkar. Sorry, guys, just to start with, I have little fever and feverish basically. I'm not well 100%, but yeah, we'll go ahead with the session. So about me, basically, as you mentioned, like Omkar mentioned a lot. So just to add more, like I have 14 to 15 years of experience in IT industry, wherein I have exposure to AI, QA, DevOps, a lot of things, which basically anything under the hood, which is called as technical. I am you find me there. So so that's about my credentials. I'll quickly share my screen. I don't waste a lot of your time, and what I'm going to share is I'm going to provide you the link as well, so that you can follow along with me. This is the Google Colab link. One second, let me just see how to message it from here. Yeah, it's chat. Okay, so I have given you the link of collab session which I'm going to share. So I'll start with it basically. So vector databases, before I go there, I just wanted to tell you a little bit about Google Colab, because and if you want to follow along, please open the link I have shared with you. Make sure you are trusting it so that you can execute the code. If not, you can copy the code and create your new Colab version over there. Now, Google Colab is a boon basically for AI individuals, data scientists, and to some extent now QA folks are also using it. The Colab, what it is, it provides a very basic view. It is a software as a service which provides you a lot of libraries which are auto installed in a way which you have to set up, or you need to it takes days or hours to set up. So it provides you the basic AI libraries. When I say basic, the TensorFlow, PyTorch, Pandas, all those stuff pre-installed over here. You just need to go Google it, Google Colab. Just open it. Come here. You will find a pop-up wherein you need to create the new notebook. Otherwise, you can create from here as well. So it is as simple as that. I'll just quickly show you how, if you're following along and new to this. So let me just right click over here, and you can see it is creating the new collab. Let it load. It stands for Google Collaboratory. It's very awesome tool if you start using it. The point is you must know about Python. Okay, so you can see over here, it's as simple as that. You can come here, simply write the code. Okay, let me write the Python code over here. Let's say I write print hi and shift enter. If I press shift enter, start running. Before that, it connects to a runtime. Now this is a serverless. I mean, it's freely available. Some portion is free available, but there are paid version as well of Google Colab over here. If you want to understand more, then you can go to change runtime type. And you can see at this point of time in this session you need a CPU only, so it is connected to CPU. You can connect it to GPU. It's free GPU available. GPUs are very costly.
So, Tony, where did you click? Like, for example, when I am on Collab, do I click connect and then start from there?
Okay, let me just redo it, Aditya, so
Yeah.
that everybody can understand it. If there's a question, thank you guys. As simple as that. Go to Google. Let's say, sorry guys, Google Colab. Okay, just search it. Open here, and if you go there, over here, this is your by default screen appears. Now,
Yeah.
um, there's a pop-up comes. I don't know, they might have changed. Yeah, it came. It came a little late. So you can create either from here or from the file structure, right? File folder structure. Create new notebook. As simple as that. It will
Okay.
create a notebook for you. Okay.
Okay.
Guys, so but before I start, I just wanted to promise you that I know it's Sunday and you have given your time. I'll make sure that it counts for you. Okay, it's an investment, not a waste of time. So you learn a lot of things. Okay, so you can see I'll go back here because it's already connected. I want to save few seconds as well. So TPUs are more higher than GPUs. Okay, they are a lot of they takes a lot of cost actually if you want to rent them or buy them. If you are constantly working on it, you can purchase their additional compute units, which is costlier, but you can check on their page how much they cost. They change it quite often. Okay. You can just select the GPU, TPU according to your need. In this case, because I want to keep things simple, I want a CPU only. Okay. I want you to select CPU and go try GPU. That's okay. But this code, what the lab is not going to ask you for the GPU. CPU will suffice. We all know CPU, central processing unit, which is quite lesser in terms of computation power compared to GPU. Yeah, so that's about Google Colab offers a lot of features. I just printed some Python code over there. Okay, you can see pandas and all those stuff, which is by default installed here. Some features like it provide you file system. You can upload your data over here and you can work with data. Okay, so maybe just let me just showcase some more things over here so that you can get comfortable with it. Let me just, this is a by default data which for testing kind of stuff they provide us. And let's say I write pandas pd equal to um, pandas. I'm sorry if I'm not good with the syntax now. I don't remember the syntax most of the times, but that's okay. It's working. So anyway, so I have copied this path to this, and this is giving us error obviously because we have to import this. Import pandas. See, I'm not installing anything. It is already installed over here. If I read the if I run this cell, this is reading this file as a pandas data frame. If you don't know pandas, I'll urge you to read about it. Okay, and let's say if I'm printing PD, so it is going to give us all the data which is available in this particular document. See, this is the data which is available in this CSV file. So it is very handy tool, very good stuff available. You can connect to Google Gemini. Most of the things are free of cost. You can share the workbook. The link I have shared, I have copied from here only. It's just like sharing any other document, Google document. Okay. So it's as simple as that, right? And I have shared this code already, which I wanted to run. If you want to change some settings, maybe theme you want to change, horizontal default and all those stuff, I mean, explore this. I'm not going to explain this because this is unnecessary for me to cover in the context of this game. Okay, in this lab. You can add some text as well. So maybe test hi, and you can use as markdown on all those stuff. I mean, commenting a lot, many things and notes basically. So trust me, I don't believe in PDF PPTs because I most of the time deal with such notebooks. So I trust these text boxes, text areas which come. They have enough features availability. You can connect with drive as well. You can store these notebooks over there. You can add new secrets. For example, OpenAI, you wanted to connect to your notebook, you can see the keep the secret over here, and you can use it with this simple code. Okay, provide the name of the, so over here the name is OpenAI. I'll just pass the secret name and I can use that API password. It will show you which all variables you have created. For example, PD we created, its type is data frame, it is shape and size dimensions basically. And over here you can find and replace and all those stuff. So a lot of good stuff. Explore this and free to use. So I mean, it is worth spending some time to learn something new. This is free of cost. Use it, explore this. So now I'll start my session. Vector databases. So first and foremost thing, um, before I jump to vector databases directly technically, I want to explain you with a basic terminology, okay, or basic analogy which you relate. For example, you are all in a fat wedding, Indian wedding, okay, you know all the things over there. Kids are roaming around, women are praising each other, for their saris and all those stuff, and then their uncles, right, who talk about everything and may not make sense either at times. But let's just imagine that wedding, and now you are into that wedding. You lost one of your friend who talks a lot, who is very, kind of a naughty person who is just going here and there and just poking people and talking nonsense over there. He's just funny guy. Okay. Now you came to a lady there and you asked her, okay, there is a guy who's my friend. We have lost him. Can you tell me where he is? The lady is very strict. She asked you, what is the name? What dress of color? What is his Aadhaar card? What is his PAN card? Give me the detail. I'll tell you where he is. Will you be able to give it? May not be. Okay. Name is okay, but you will say, okay, I don't know the Aadhaar card. And why the hell is she is asking me the Aadhaar details in the marriage? Okay. That doesn't make sense. Now you went to some other guy and you asked him, that person, that okay, there is this guy who's making a lot of noise, who's talking rubbish and all those stuff. He's going everywhere. He just you will observe him just because the way the person is. And someone from that pool of uncles, one came out and said, okay, I'll tell you, there are four people or four boys rather who are making a lot of noise. I think that what you are saying means matches to that particular crowd. Go and find him there. So uncle did not needed anything, name, nothing of that sort. What he went on is a thought process that okay, he's asking about something which matches the description of I have seen something. Okay, so he will tell you to go there and you will find your friend. High chances, right? Now AI, we all know, all works on probabilities. So again, here in this case as well, we talked about the probability only. The uncle thought that you are looking for something similar and he gave you the direction to go there. Now that's exactly is your vector database. And the auntie which was asking you everything is a traditional database. Okay. Now most of the times traditional databases don't simply work with AI. Okay. You can imagine the unstructured data, you can imagine the quantity and the volume of the data. You can imagine the type of data. It's PDF, NLP data, and video, audio are there. A lot many ways you can see the data AI uses, right? Excuse me. So that's about um, the data we have in the store. Now just imagine if I ask you to store your images in a database and I wanted to retrieve it. How you retrieve it? In a traditional database, you simply cannot, right? Okay, if I ask you to store somehow, if you manage, let's say for example, you make an entry that this image is of this day and this event and this attire, maybe you can able to retrieve, but not actually, but not, it is not going to be a very efficient way, right? But just imagine if I query that I need my uh, just need my images wherein I'm wearing a suit or maybe only t-shirts. Okay, so it will give you that. AI will give you that. How? That's actually the vector database is doing the job. Traditional database are gone there. There are two types of vector databases. One is a vector and the graph, not vector, but two kind of databases AI deals with. One is a vector, which is mostly and widely used. Also, there are some drawbacks. To overcome those drawbacks, uh, people have researched about graph databases. So now today I'm going to introduce to vector databases. Some other day maybe we'll talk about graph databases because maybe they have something similar but lot many things uncommon. So we are going to focus on one at this point of time. Let me take you to the school lane. If you remember, we learned a lot about scalar and vector. Just go to your school times or college times. You just remember those days. What is scalar? Any number which has a value is a scalar, right? Maybe a negative number as well. The absolute value becomes the scalar part. -3 has a magnitude of 3. Okay. So there's a scalar which has -3 value with a magnitude of 3. Something which is a vector, basically imagine a point in 2D space which has coordinates as 3 and 4. Now if you draw a line between 3 and 4 in 2D space, you will see a small line which is joining with a magnitude of 1, because they have a difference of 3, basically 1. Not actually the magnitude. For magnitude we need to apply the Pythagoras theorem over there, but I'm just saying to make you understand. A 2D point in space 3 and 4, the line between 3 and 4 is your vector. It has some direction. See here, it is coming from 3 and going over 4. It has direction, it's going upward. It has magnitude, which you can calculate through Pythagoras theorem. Okay, it has a tail and a head, so that's the vector for you. Okay, it was very easy to imagine because I told you it's a two-dimensional vector. If I increase the dimension to 3, still it is very much comfortable. You'll scratch a head for a second, but you will be comfortable over there to imagine it. Now imagine 21,000, okay, vector uh, vector values over there. Can you imagine? You simply cannot. Now just imagine now, which you cannot, but just imagine that these many dimensionalities are used by AI. 21,756, um, and any number it's which is unimaginable. Okay, so chat gpt uses 21,000 dimensions vector databases, or basically vectors, not the databases. Databases actually store them. We'll uncover all of these things. We'll go ahead further, but now I hope I have made the ground very much clear that what we are looking for and where we are. Okay, vector something which has a direction and a magnitude. 3 5 7 2 4 in 3D space. Okay, what we operations we perform, we do addition, scalar multiplication, dot product of a vector. Okay, so I'm not going to worry you or make sure worry you with the formulas for this. You don't have to remember. Good thing is AI does it for us, so we don't have to worry about it, but we need to worry about the understanding part. Okay, so as I said, it to calculate the magnitude, it uses Pythagoras theorem, square root of and then so over here 3 and 5 the magnitude is basically, sorry, 3 and 4 the magnitude is 5. Okay, so square root of 25. So that's how it goes. Now, have you ever imagined that I'll come back again to some another example of where vector databases are used before, so that I'm giving you more examples so that you can relate more and you can understand more. Now just imagine if you go on Amazon or Flipkart, you search for a good chair. Okay, um, let's assume that you are searching for a three-leg chair. Okay, I know it's strange, I mean nobody does that, but let's do it in our thoughts. Do you think will your tool will be, or Amazon will be able to provide you that? If it has, the answer is yes. If it does not have, what it does, it is going to give you chairs with 4 legs, maybe 8 legs, maybe some shiny 5 legs or whatever, but it is first going to give you the 3-leg chairs. Now another example, let's say you search Google, how it has a capability to provide you the relevant links, URLs. You are just typing in some text over there and it is coming back with awesome answers, right? And very fast. So that's the power of vector databases. They are all using vector databases. Vector databases are proven in terms of the similarity searches. When I say similarity searches, go and search for Toni. Whatever or whoever people with name Toni will be searched as a similarity. Maybe spellings will be changing with respect to some conditions or whatever. Okay, with good grammar or something. I don't know what, but I'm just trying to make an analogy over there. Now, why these things matter? Now, I think I have given you enough ground to understand to what exactly we are trying to cover over here. But why this is why this matters basically? So vectors are very fundamental in AI and ML because they allow complex and unstructured data to be presented in a structured and numerical form. What machine understand is numerical form. Machine will never understand natural language. Okay, AI generates something, some text, but again that text for us it is text. For AI, it is just a probability. Trust me, it is probability. What AI is generating for you. Generative AI is all about probability. It is not something very rocket science over there. So it is, for example, when I say AI and it automatically give machine learning because probability of coming machine learning with AI is higher than let's say AI and ground or maybe cricket or maybe football. It will there's a very less probability. That's why it gives you AI and machine learning. Okay. So I have given a lot of understanding over here. Please go and read about this. I have already shared this because I want to showcase you practical implementation. Some of the things I'm covering with examples. Okay. You read and you can relate over there. Now, vector databases, what are these basically? And why do we need them? Just imagine I told you, right? For example, a text is, sorry guys, I have sore throat, so I'm just drinking in between. Uh, so just imagine storing these high dimensional vector data. Is it not? It is not possible with normal databases. So here vector databases comes into the picture. What vector database stores basically an array of numbers which are vectors, and those are very high dimensional vectors. And there are certain models which are created in machine learning and deep learning which accept this form of data, and they call it as embeddings. Okay, so you might have heard or not, I don't know, but embeddings is very common word in AI. Embeddings are numerical representation of complex data types like text, images, audios, and whatever. Okay, whatever you see there coming. So um, I'll tell you one more example to explain this better. So for example, if I say the cat sat on the mat, okay, and the feline rested on the rug, these sentences are very simple, but they have almost similar meaning. Okay, they have almost similar meaning. The cat sat on the mat, the feline rested on the rug. Okay, if I ask AI, then it will try to match them because they have a simple meaning, and that is resemblance to each other. Okay, that's how it works, as simple as that. Now just imagine, I'll take you one more example to explain you how it is relevant over there. So maybe for example, I'll take the classic example which everybody takes so that it's fairly simple to explain. Now just understand, there are men, there are king, queen, and the girls. Okay, now what common thing uh, a king has? He is royal. Okay, man is royal? No. So let's give value 1 to royalty point. And in your mind, create an array. First, royalty, value 1. Now create 4 arrays: men, women, king, and queen. Royalty will be 1 in both king, queen, but in men, women, it will be 0. Let's go ahead and see another point, which talks about strength. Men and king may have higher strength because physically uh, men are more stronger. So let's give them 1. And women, because they are stronger as well. It's not that they are not stronger. So let's give them not 0, but let's give them zero point 0.8, and to men we'll give zero point 0.9. Okay. Now add on features and create a big array. Now you will see man and king have somewhere similar features, but king and queen also have some similar features. Man and woman have also some similar features. But these vectors which you are imagining with respect to certain conditions or certain aspects have formed an array. Men and king may be more closer to each other in terms of all the factors. Gender is one factor. Vocal, let's say vocal strength is one feature. A lot many features over there. Okay. so on and so forth. Now, this is how it stores the data. The cat may have some embedding number associated with that. Set might have some associated number on the mat. Okay, so on and so forth. Rested and set very much close to each other. Okay, that I hope you are getting that point. So now let's go on. So now I have already given you a comparison, so I'm not going to take you through this because a lot of examples we covered and it speaks about that only. Where it is used. Semantic search. Suppose you want to search for the how chatbots performing, how generative AI is working on the similarity searches. So you talk to a chatbot, you ask them, okay, my food product which I ordered was not good. So it is doing a similarity search and it is trying to give you the answers from the pool of answers, or maybe generating the new answers with respect to your semantic searches. So basically a similar kind of answer it is give. My product was not good. So it will say, oh, sorry. Or we are happy to help over there. Do you want a reimbursement, or let's say you want to replace a product, right? So that's where it works on the similarity searches basically and semantic searches. Recommendation system. So if you go and search for one movie on Netflix, it is going to ask you, okay, this is, you watched this, that's why I'm showing you this. You ordered this thing, that's why giving you this similar products. Image and video search. I gave you one example, okay, of chair. Anomaly detection. Very critical aspect, anomaly detection. What happens basically? These vectors are storing some values against some text or maybe something uh, similar, right? So if pattern changes, the embeddings are changing, and that's where you can find the anomaly detection. A lot of cyber security and all those stuff, they uses vector databases to understand how, at very grand level I'm talking about, how the anomaly detection is there. Okay, there's one more example. I don't know. I read it somewhere. It's way back as well. Not too much old, but 1 or 2 years old. Um, a person did what it did is, if he did AI, he created his own AI model on top of, I think, ChatGPT or something. What he did was he provided a lot of data of stocks he was watching over there, and he was constantly looking for the anomaly detection using the vector databases, and he found one pattern over there, and he earned good amount of money. There's a use case as well on CNN Business, something where they showcased as well. But somehow, I mean, obviously in real world stock market, it's not always true, but yeah, it was giving him enough idea so that he can even edge and over the other investors. So that use case, there's an interview as well on YouTube available. um, More examples, please go on. When you read up on this document I have already provided, which are the vector databases available. Now this is a very good diagram taken from Google. Again, you can search and read about it. Some of the open source are Chroma, Vespa, and Quadrant, Milvis. These are the open source. You can go use them. We are going to use one of them over here. Source available or commercial, so closed source basically. Pinecone, very good tool. Waviate, very good tool. These are available paid. Some of the old databases which are now supporting uh, these vector or vector searches basically is PostgreSQL. I'm sure you might have heard this. Elasticsearch, Single Store. These are paid ones. These are open source, but they are supporting in this quadrant. They are supporting the vector searches basically. So that's all about the theoretical part, and I hope I have given justice with it, because I know I have taken time, but this is very important to understand. See, this is the example I was talking about. For object one, the embedding grid generated zero point 0.5, 0.6, it searched the similarity with how it searched basically. So cosine similarity. I'll talk more about it. Okay. Um, just quickly, and then we'll jump on the execution part. Now, similarity search happens with 3 to 4 types. One is cosine similarity. We all know how cosine works: sine wave, cos wave. Just imagine that. Now, whichever these what you call the vectors are similar to each other, they have less theta, which is cos theta, right? So this how it works basically. So if you calculate the cos or cosine of these two vectors, you will find that um, their angles are, or cos thetas are basically close to each other, and they that's how it generates the similarities. One is the Euclidean distance. Euclidean distance measures the straight line between the points in a high dimensional space. So basically, what it says is very simple. In cosine, we were dealing with angle. Over here, we are dealing with the distance. So whatever is the imagine 2 points over there. What is the shortest distance between the 2 points? These are similar. Okay, as per this. And Manhattan distance, basically, there's one more point where it calculates L1 norm. Basically, they have some formula. Um, I'll not go there because it will just take a lot of time. But just imagine there are like we are creating the absolute values between the point A. So basically x1, x2, and y1, y2. And these absolute distances, whichever is closer, and then it is going to give us the idea over there. Okay. Um, Now over here, I'm going to install the transformer libraries. Let me connect this. Now we are going to um, do the practical execution. Okay. Um, So I just executed this before joining here so that we can save some time. Okay, I'll explain the code although. So I'm using the transformer library. If you don't know transformer is the reason why we have ChatGPT, why we have AI today, what we see today. Transformer is basically based on a paper from Google resources, and they created a paper called as Attention All You Need. Transformer is just name given because there's no role of word transformer over there, but they were not liking the name attention is all you need, so they gave the name as transformers. So attention all you need, basically I'll just briefly talk about it for a second so that you understand the way I'm talking to you. What you are doing, basically you are focusing on the some of the keywords. So for example, I will say hi, how are you, right? So you are not going to remember each and every word in the sentence, but maybe hi, how are you is very common word, that's why you may know, but let's assume a different sentence over there. So let's read this. These concepts from the foundation and the understanding and utilizing vector database in AI and ML applications. Now, while I was reading this, you might have forgot the grammar of it. Like when I say grammar, not actually the grammar meaning of it, but some words. So, for example, the for and you might have missed this, but what you focused on these concepts. So, concepts a keyword for me. Understanding vector databases, utilization, AI and ML. So these are the keywords from me from this sentence. What this transformer does is it focuses on the keywords so that the actual meaning is understanding in a smarter way. That's how transformer was invented. The way human thinks, that's how that's where it thinks basically. Um, Transformer, we are importing BERT tokenizer and BERT model. Now, what are these? BERT tokenizer is basically when I'm talking, I can divide each and every word in tokens. Maybe one word or subword can be one token. Tokenizer we can talk someday later. But I have one more thing. I have given a very good document. I have created a very good document over here. In this case, whatever I'm talking about, you will read at length. You can read over here. It's a Medium article. I'll give you. It's a very big article, but once you read it thorough, you will it was highlighted by Medium as well. So once you read it thorough, you will understand it at length. um, for now, understand tokenizer is something dividing words into, let's say this is one, concept is two, from is three, so on and so forth. BERT model is basically going to convert our sentence into embeddings. This is open source model, freely available, go and use it. In this case, it generates 786. um, Yeah, one more good thing of Google feature, if you utilize it, it will give you some details, and it is written that the paper as well, the paper I talked about, right? This is the Google paper by Ashish Vaswani, which talks about transformer model. A lot of good information by Google as well. Once you go and hover on the on the class which we are using. So BERT model generates your text into I'll go real quick. Text into the embeddings. Um, I'm loading my tokenizer. I'm in one array basically, and I'm using the BERT base cased uncased model which is available in Transformer only. I'm importing Torch model. PyTorch is a library basically which I'm using. It's a package basically for machine learning. Okay, you can read more about it as well. I have just 1 hour, otherwise I could have covered. Um, Model basically the AI model or the transformer model which I'm using, which is called as BERT model in this case, and I'm analyzing or instantiating one model over there, and I'm putting in the text which is called as the cat sits on the mat. Now input IDs. What are the input IDs? So whatever tokens I have created, I'll convert into an array which AI understands. So I'm converting into the tensors basically. Tensors are the high dimensional arrays. And now these input IDs will go to the model which I have created or assigned over here, and it is going to create the embedding. So I'm going to store them in the variable called embedding, and I'm printing this. When you run this, it takes some time depending upon your internet connection, but it is going to install this tokenizer and all those stuff. And then over here, I'm printing the embeddings. See, these are the embeddings from this model for the text which is called as the cat sits on the mat. Now I'm going to showcase you the similarity searches basically. So let's assume that I create a vector one which has some array value over here, vector two which has some array value. I've just randomly given these numbers. Okay. Now I'm going to calculate the similarity. So for that cosine similarity, which is part of the isquareit library, which is already formula is there. Formula is simple as well. You can directly run this formula on this, but over here there's already available in scikit-learn package, which I have imported over here. Now I'm printing the cosine similarity. So these two vectors have cosine similarity of 0.66, which is greater than, like, let's say 0.5. So these are in a way close to each other. Okay. Now that's how cosine similarities works basically. I wanted to show you. You can run this. It's fairly simple. It will run. Okay, let me run this and show you. Torch is not defined. Sorry, I need to run the abo command as well, because I need to install that now. Because yeah, one more thing, because we are not using the paid version. Every time you reconnect, it will ask you to install. Okay, which is not there available. So in this case, I need to install Torch. I don't want to waste your time, but you can run that part. Now, there is one example which I'm going to cover, which is called as FAS vector database. Now, FAS is a Facebook created vector database. It full form is Facebook AI when it was not Meta AI, I think. Facebook AI similarity search CPU version. Okay, there's a GPU version as well, or full FAS. I don't want that. I want only CPU because I want to showcase you on the CPU side of it. I am importing NumPy as NP so that I can create vectors automatically using NumPy. Over here, I'm creating a random vectors, np.random. I want 100 vectors with 128 dimension and its type is float 32. Okay, I don't want the integer, I want in float. Obviously, they go in float. Normalize the data. Now, why normalize? Because in float, maybe they have, like, just let's assume that 0.34, something like that. I want to keep to one only, like 0.1, 0.1, 0.2, something like that. So I'm just normalizing my data. Create a FAS index. So I'm using index flat L2 method, which is available in the FAS vector store. So over here, I'm creating the index for all these data basically. Now index is something which makes it faster. It's again some, you can say, a memory which a pointer. If you remember C language, it creates a pointer over there which is addressing to this particular data location. Now I'm going to query this vector databases. For querying, I created one embedding, another one embedding of 128 dimension. Okay. Now this query vector will be, I'm querying against the randomly generated data. Okay. And we'll see how it basically defines that. So I'm going to perform the search and I want to calculate distances and the indices. Now I want to perform first 5 searches. Now this is one more feature over there. So maybe you want to search for first 10, first 5, first 2, first 1. So I'm looking for, so you need to keep value 5, k equal to 5 in this case, because we are searching for the 5 most similar vector searches. So I created the index. I'm calling the search method. I'm passing the vector query over there, which I created before this. And I want only 5. There are 100 of the vectors which are available, which you created. Why I want only 5? Now when I run this, first it is going to install fast, because if you don't have, it is going to install. Once it is done, see, it is giving you the index of most similar vectors which were created, because these are randomly created. As a result, sequence is also random. By indexing, they gave a memory storage, and it is going to give you the index, not the vector. And over here, it is we are printing the distances between them. So it is printing 0.4. So the most similar ones have a norm, a way range of distances is 0.4, 0.4, 0.4, 0.42, 0.42. That's how basically it works basically. Okay, now one more thing to showcase. Let's assume that we created the embedding. Somebody asked this question to me in the past. That's why I have added this. Um, so I have the tokens, but I want to reverse engineer it. For example, I want to, I have the sentence, I convert it into embedding. Now I have the embedding, I want to reconstruct the sentence out of it. So now, will it work? 99% or 90% of the time it works, but at times it fail because sits may have similar words as well. So if it is, let's assume that um, sit have another word. So there is a possibility that instead of sit, it may come, but 90% of the time it gives the right answers. Okay. Um, One more example I would like to cover. This was about the fast CPU. Sorry, anybody speaking? Any questions or something?
No, no, all good. Thanks, Tony.
Yeah. Okay. So this is about fast CPU, which we use the vector database over there. Now, ChromaDB. Faz was not, name was not there because it's not that very extensive tool. So one second, guys. Sorry. Yeah. So ChromaDB, I'm going to install the ChromaDB, Chroma database over here. Again, I'm going to use the similar transformer library and torch library. And when I execute this code, um, what we are doing, I have showcased with one diagram. But when I execute this, it is going to install in this instance. You have to make sure that you are connected. Over here, let's assume this is your application. Okay. And your user queries the, let's say the software. Gen AI embeddings. So basically over here, let's assume that you are using the chat OpenAI embeddings model. So there are a lot of embedding model. One we use BERT. Um, some of them are fast, very fast. Gen AI is 21,000, so it's more advanced and more good results it produces, but it is again some cost associated while using the APIs. And it is stored, the ChromaDB has a power to store these embeddings. So this document, let's say call me smile, something like that, whatever is done there, this taken from ChromaDB's website, official website, and they generated the embedding like 2.1 something, and it's very big number, we cannot even imagine. Okay, now query will also be converted into embedding. Whichever embedding model you are using, it will be same, so that more accurate results are given. Now it is going to query these embeddings. All we see the document, but under the hood it works on the embeddings type. And then it is going to provide the LLM the context, and LLM is going to answer based on this context. So this is how the most of the AI chatbots, RAG and all those stuff, or whatever you call it, maybe for example Amazon search and all those things works. Okay. Now ChromaDB, what is that? Is a vector database, as I said. It is very efficient for storing high dimensional vector databases, and unlike like traditional databases, There are rows and column. It does not have that. It can store very complex numbers. It is very efficient. Again, there are lot many tools you can use, but this is free to use. So most of the time you'll see this is available and widely used by the people. Scalability, very easy to scale. It provides or it helps on the distributed data as well. So maybe if you have your machine, single machine cannot simply load the data, it is going to give you um, data distribution as well. So that multi-node, basically hub and node kind of work. Integration with AI model seamlessly works. Okay, a lot of it's simple Python code we'll see now. So once you install this, it is going to take some time and it's going to install this. Then I'm just doing the imports, which I spoke about, and how we can initialize this. For that, you just need to call the uh, object of ChromaDB and client class, which is there. That's it. You have initiated the uh, Chroma database over there. Now, in this case, I will look if any, what they call is basically a collection. Over there, we see the tables and the schemas and the views or something like that. But in this case, it calls the data as collection. Okay. So first, we'll see if any collection pre-exists in this database. Obviously, for the first time, it is not there, but just in case. Okay. So we'll delete that collection. And then the collection, we are going to create a new collection with create collection method. As simple as that. Just like any other database connection you do. In fact, more simple than that. What I've seen, like Oracle DB and all those stuff, you need to provide more details, username, password, and the schema and all those stuff, and then the database name. But in this case, we just creating collection. So you can create multiple collection 1, 2, 3, or maybe whatever. Amazon collection, Facebook collection, whatever. My application collection, your application collection. So over here, I'm just deleting one, creating new one. Again, tokenizer. You need to remember this because in AI, everything, it specifically in text, if I talk about, or images as well, they break things in tokens. Okay, and then give a number to each and every token, and this numbering given by the models, which are deep learning or machine learning models, which are created under PyTorch and all those stuff. Um, and then uh, I'm going to create load the model. This is pre-trained model. Okay, and you can use ChatGPT and all those stuff here, but I want everybody to run this and understand this. That's why everything is open source. You load the tokenizer model and you can set to the evaluation mode so that there is no further training specific layers are available. So basically, in a technical word, you just say maybe you are just going to lock it, okay, in a way. Now I'm going to generate the text embeddings. As I said, I mean everything goes in a form of the numbers, nothing else. So we are again what I did previously. I just over here I'm just changing my database. Everything else is mostly same, right? You can see the code is also not changing. It is same. I created the tokens and the embeddings. These are stores. Now, for example, my collection has these text available. I'll read it out so that I can explain you. You can add more and run this particular example. The cat sit on the mat. A quick brown fox jumps over the lazy dog. AI is transforming the world. The sun set in the west. Data science is fascinating field. ML model can generate surprising result. Surprising result. Deep learning has led to the significant breakthroughs in AI. Something you might have observed. There are some random sentences, but some sentences which are related to AI. Okay. Now I'm going to generate the embeddings for all this collection, which I have created. So I'm going to go through a loop, and then I'm using collection.add simple Python code because over here I'm just adding into a you can say a dictionary kind of thing, um, where I have IDs, document embedding, and metadatas if any. So these are going to store in the collection. Now I want to query this database which I have created. So I'm going to ask machine learning is a rapidly evolving field. This is my query. And I want to see how my database is reacting to this. Okay. And then I want the top three results from this. So this is the query I created. I'm going to query this to my database. Imagine it's a Google and it's a Google form, and I'm querying this. Machine learning is a rapidly evolving field, and it is available with only this data set, nothing else. I have to convert this query into embeddings as well. Basically, the model will do. So I just need to pass this, um, and I'm going to have the results. Basically, results I want in a result variable, and this is going to query the collection with query embeddings, and a result I want top three results. You can change to top five, top two. In this case, keep it low because we don't have much example. You can add more examples and um, see how the result varies or not. Now, this is the code, simple code, and at the end of the day, I'm printing how it looks. That's it. So when I run this code, you can say it is going to install this. If you remember, my query was again related to machine learning. So my query was machine learning is rapidly evolving field. Now from the bundle of text, it is giving me data science is fascinating field. Yes, it is relevant. Deep learning has led to significant breakthroughs in AI. Relevant. AI is transforming the world. It is not giving me the story about the lazy frog or the cat or something else. It is giving me relevant results because it's machine learning, data science, deep learning, AI are the relevant fields. As a result, it is no way giving me anything which is related to you know what was that? Let's read it out. The quick brown fox. No, it never gave me. You can add more. So there were four sentence, but we wanted top three, right? So it gave us top three. Maybe you can explore this part and you can understand more. Now, if I ask for top seven, it is obviously going to give you this because two to three reasons. One, we are using the open source model, which is not that good. Okay. Second, you are you are forcing it to give the seven results. Just imagine replace yourself with the database, and if you force somebody, okay, you know you have eight lines, but I want seven out of them. You're forcing them, so it is going to give you that answer anyway. But the point is that's how it works. Okay, so I am done with the explanation, and any questions? I'm opening this floor for the questions. I'm giving you this link of the medium so that you can read it. Very thorough examples are written over there. All of them are open source, so nothing is stopping you to explore this. Okay, this is my LinkedIn profile. If you want to connect with me, sorry, I don't know, something wrong there, but yeah, if you want to connect with me, please come. Feel free. Ask me any questions if you have further. Oh, I don't know, something is wrong. I'm not able to find myself.
Or you use vector databases.
Anyways, that's a good one. But yeah, this is about me. You can come talk to me if you have any further questions as well. I see a lot of posts which are on ATA GTR 24, which is good. Um, and some one more thing about me, I'm very much I have a lot of I'm very adventurous and athleticism in me. I do a lot of things. So even apart from technology, if you want to go for cycling or something, I'll take you there. Maybe of the time. Yeah, but that's about me, guys. If any questions, I'm happy to answer there, and feel free to connect with me on LinkedIn um, and bore me there. Yeah,
Yeah, very nice, Tony. I think it has been a great learning for me, and I'm sure that whoever basically attended this lab session, this is one of the best sessions that I've ever had. You made it really practical, no presentations, nothing. Everything that you showed was clearly explainable and amazing indeed. So I had no clue what vector database is, and now I understand something, and I can talk to people on vector databases. So great
Yes.
stuff.
So Aditya, I was also going to say the same thing that he started from the basics. Means people who are not aware about what is vector, he started from there. So that was very helpful, I can say.
So any questions, guys? Yeah.
yeah, I'll be happy to take.
We have, I
If
think,
not,
I We have
Yeah,
around 5 minutes. How much time do we have?
3 minutes.
3 minutes. Okay.
Yeah. If not, I mean, you can reach out to me on LinkedIn as well. You can bother me there. That's okay. I can take that. But yeah, I'll be happy to answer, because if you have questions, then there's a high probability that others might have the similar questions. So I'll be happy to help there.
So I think the session was taken in a manner that you took it baby steps and you explained step by step everything, including the way that you actually loaded the all the statements, and then you did the search and you took out the similar one when you basically did that. You earlier explained cat and feline, and then you showed it using a real example. Um I think if I could understand, anybody can. So I'm probably newbie to this field, and if I can understand this, Tony, it's amazing.
Thank you so much, Aditya. This is I'm glad that it helps
Big time,
others.
big time. I would say
So,
that
Tony, I
I
have one
wish
question.
more people had attended. Ajib, go ahead.
Yeah. So we have seen that this particular vector database we are mainly using for the finding the similarities. So what are the
Correct.
different other applications to use the vector database?
A lot many. Basically, you will see gradually the adoption is increasing. Now, I'm not saying that it is going to completely remove the traditional databases. That is not practically possible. Um, but wherever there's a large data set, and there's wherever there's you'll see AI is somewhere and machine learning are somewhere part of your solution, you have to use that. Okay, so anomaly detection, I told you time series. So where time series data is there, right? So stock prediction and something like that. And again, obviously in e-commerce, de facto way of uh, using it, I'm going ahead with this vector database. Okay, traditional database are slow comparatively, and and that's where e-commerce is basically the big, I would say, biggest client of vector databases. Google searches, any search engine is there, they have to be very fast, and over here it just deals with numbers. That's it. It does not deal. So imagine you are querying something. Imagine I want to search for the yellow buildings, and on the other hand, if I ask you to search for plot number 256, okay, which is easy for you? Yellow buildings, right? So that's how it very efficient, very fast comparatively. And the good thing is it converts everything into number, and which makes it very much faster mathematically. Anything can be done faster by machine. So over there you apply the filter in database. But again, I'm saying on the small scale ones, you still believe I would still believe that vector database is not a good thing on small scale solutions or applications. But on the large scale applications, or maybe very faster executions, you need these vector databases. Something called as graph databases are there, which if someday, some other day, we'll cover that. I'll talk to Aditya how can we do that. But yeah, most of the time I think there is one more thing, which is graph databases, which are taking the all the attraction now. But again, you cannot replace things in smaller ways. But on the e-commerce side, or on the major players which come, Blinkit, your Ola, Uber, all of them are using vector databases because they want to expand and grow, right? So uh, wherever you need faster solutions, you need to go there.
Yeah, thank you.
Sure, Rajiv.
Uh,
MongoDB is a vector
we have
database.
a
Yes.
question. Yes.
MongoDB is both basically. So MongoDB, see, obviously, tomorrow, let's assume you have a shop, right? And you want to compete with the market, you have to offer some other features as well. Very much work uh, considered in MongoDB's case. MongoDB's traditional database, then it went for NoSQL, then now it also supports. So basically, MongoDB has everything in it. Um, they have graph database as well. It's a store, right, for them. They just don't want to go out of what you can say, the train, right? I hope that answer. The answer is yes. Not actually full answer is yes. Vector database is one of the part of the Mongo database, and they have started giving us giving this feature recently only.
So, Tony, any NoSQL database can be considered as a vector?
Sorry, you breaked. What was that?
Any, uh, any NoSQL database can be considered as a vector
No,
database?
no, no, no. You are still querying there, right? In the form of JSON. Over here, you are querying with respect to cosine similarities or equivalent distance. You are not passing any hardship values over there. In NoSQL, you are passing those, right? Because
Yeah.
in NoSQL, in a way, it can be used, but again, there are some tri uh, tricks we can do that, but not actually. The answer is direct answer is no. Indirectly, you may have find your ways to do that. Technically, everything is possible, but mm, efficiently, I think no.
All right, thanks.
Yeah.
Okay.
Hello. Actually, I have a question. So, Tony, just wanted to know, what is the latency time for this database comparing to the other databases? Like, how fast we can get if we query something, we can get a value of it comparing to the other databases.
It's very fast. Okay, I may not be tell you in numbers right now, but again, that depends on the embedding model. So, for example, okay, I'll give you like example which you have used or everybody have used. You use ChatGPT, right? How fast is responses you?
Yeah, like it does used to take around 1.9 or 1 seconds around. Like if
It is
we
that.
the
It
answer,
is that
yeah.
only.
Hmm.
Okay.
Okay. Yeah, sounds good. Thanks,
Yeah.
Tony.
Yeah. Okay. I think that's it, guys. We are over time now. I don't want anybody else time to go by.
Thank you so much, Tony. Thanks a lot.
Yeah.
Okay.
I'll just stop
So,
share.
yeah, Omkar, can you just have the thank you slide? Yeah.
Yes, yes, yes. So, thank you, Tony, for this valuable session. In spite of you being uh, sick, so that was very grateful. For you. So, yes, we have completed the session on vector database on the realms of AI, and that was a very great session by Tony.